Assalamu alaikum students. This is our lesson related to work, power and energy. First of all, we deal with the work done. I have gone through a preface of this chapter in which we just discuss some energy transfers, some energy sources. Now we are starting formally our lesson with the work done. In order to save the time, I just have written some information on the sheet. What is the work done? When a force is applied and the distance is moved in the direction of force, then we say that a work is done according to the physics. And this means that it involves two quantities. One is force and one is distance. Distance should be in the direction of force. If it is not in the direction of force, then you cannot calculate work done. Now F stands for force, S stands for distance. This means that its units will be Newton meter. Newton for the force, meter for the distance, and Newton meter, that stands for joule or joule. So the work done unit is joule, which is equal to Newton meter. If the distance is covered in centimeter, then the unit will be Newton centimeter, but that cannot be equal to joule. You have to convert the centimeter into meters. So this is basically a condition. Fine. Now we have an example how we can calculate the work done. Here is a ball of any kind of mass, and there is a force acting on the ball to push the ball, and the ball finally moves in here from position A to position B. I just write down the values of these forces. Just wait a minute, I have to arrange some writing material. Okay, let me give some values in here. This is the position A. The ball moved from position A when a force of suppose 100 Newton is applied. It is pushed and cover a distance. I just marked the center of gravity for the distance from position A to position B. Now that distance, suppose that is 10 meter after the application of the force 100 Newton. Then the work done will be W is equal to F into S. Now this was the direction of the force and the distance was also covered in the direction of force, so we can apply this formula now. Now the force is 100 Newton and the distance is 10 meter. We get 1000 Newton meter, or more accurately it's a joule. It's 1000 joule work is done by this force. But in the practical life, these things are not possible. There are some friction forces. Let's take another example in which we consider the friction force as well. Take the example number 2. There is a ball, there is an object. This is called an object A, and it is moving from position X to position Y. This is the object A. When we apply the force of suppose 100 Newton in the right direction, it covers a distance of suppose 50 meter. But meanwhile there is a friction force in the opposite direction, which is suppose 20 Newton. Now there are a different question that can be asked. Work done by 100 Newton force. Secondly, this is your question part A. Now the part B is work done by friction. work done by frictional force. Frictional force. And the third is net work done. Net work done or resultant work done. So let's start. Work done by 100 Newton force. The formula remains same. The formula remains same. W is equal to F into S. Now the force is 100 Newton. Distance is 50. So 5,000 joule work is done by this force. Now there is an opposing force. That is again F into S, work done by the opposing force. Opposing force is 20 and the distance moved is 50. We get answer 1000 joules. Now net work done will be 5000 minus 1000. That makes 4000 joule work is done on this block. There is another way of doing this. If you initially take a resultant force, 100 minus 20, that is 80. 80 is the force and 50 is the distance moved. You again got net work done 4000. So there are two ways of doing this, but the question was very clear. He was not asking at the start that you find the work, the net work done. He says first work is done by the 100 Newton force. So you have to go through this. W is equal to F into S. Then he says that work done by the friction force. Then you have to consider the friction force and the displacement moved against the friction force, and then the net work done. So that whole lot we are dealing with this formula. Work is done, F into S. You note the definition and you note the calculations, and let's move forward to its third phase. It says that when a work done is zero, work done is zero, work done basically W is equal to Fs. Work done is composed of force and displacement. If there is no force, work done is zero. Let's say there is no force. If F is zero, W will automatically will be zero. You are not applying a force. Mean that if you go to the above example, if there is a 100 Newton force and there is a 100 Newton opposing force, frictional force, so 100 minus 100, that makes a zero force and there will be no work done. So this is the case. Similarly, the case of terminal velocity as well. Just let me assure you, a ball is falling with a weight 10 Newton and the air resistance 10 Newton. The work and it falls, and it is covering some displacement, but there is no resultant force. So there is no resultant work. Work done by the weight is equal to work done by the air resistance. So they will cancel out, and we say that there is a no resultant force, therefore there is a no resultant work. And there is another example. If this is the wall and you are this is the wall and someone is applying a force on it and it is not moving, means no distance is covered, then F is equal to, there is a force but there is a no distance. The work done will be zero. If no object is moving, then the work done is zero. Come towards the third example, very familiar. If we have a circular motion, let's make me a circle. All right. Let me go again. Here is a circular motion, and we know that in circular motion the force is always directed towards the center of the circle. the resultant force is always directed towards the center of the circle, and the direction is motion is the tangent. It's just like that. It's just like that. Direction of motion. This is velocity. This is force. This is force. This is velocity. Now this work, why this work done is zero? Because the distance moved in a circular way that is not in the direction of force. Work done says that the displacement moved must be in the direction of force. In the direction of force. So that will be a work done. So we says that no distance is moved. No distance is moved. So no work done. No work done. So this is our discussion with the work done. We have a third example, and then I will finish this topic, because we have a test today, class test, and half lesson goes in the test, and the half lesson will go with the explanation or introduction with the work, its formula, it's some small examples that I have given to you. Now let's discuss its formula once again. It's force into distance. Work is joule. Force unit is Newton. This is meter. So joule is equal to Newton meter. Work done is a scalar. It's not a vector. It's a scalar quantity. You must remember this. And most likely, if you says when the force increases, work done increases. If force decreases, work done decreases. If the displacement increases, work done increases. If the displacement decreases, work done decreases. So that's all about work done. In the next lesson, we will go to define energy. Now, energy is a bigger topic than work done. It deals with form of energies, formulas, their convergence with each other. Basically, work energy power is mostly based on energy and power. Work done is just a very small part of it. So thank you very much. मैं इंशाल्लाह कल नेक्स्ट लेसन में इससे हम आगे स्टार्ट करेंगे. ठीक है जी. थैंक यू.